Hello. So, sorry for the audio issues, but we're now going to get started on our review session today. So, hopefully this will run until 7:30, so we have 2.5 hours. Ella will start us off by going over the paper 1 for last year's May 2024 math SL examination paper. So,
Okay, hello everyone. So today we will do paper 1 and 2 from last year's May session. So first off, we'll just briefly look at the rules for paper 1. This paper, you're given an hour and a half to do it, and then you're not permitted to access any calculator for this paper. What? Close the mic. Close the mic. Okay, sorry guys, there were some other technical difficulties. So now we'll get started. So for paper 1, you have an hour and a half to complete it. You are not permitted access to any calculator for this paper. So you have to do all the calculations in your head. And you will need the SL formula booklet, which will be provided to teachers. And the maximum mark for this examination paper is 80 marks. All right, let's move on to the first problem of today. So the second term of an arithmetic sequence is 10 and the fourth term is 22. So part A, find the value of the common difference. So my bad. So part A, so we know that the second term equals to the first term plus the common difference. Oh, here I'm using U because the official formula booklet uses U for the sequence and series stuff as well, which is a little different from what we're used to, but it's just a variable, doesn't really mean anything. And then for the third term, it equals to U1 plus 2D, and then the fourth term equals to U1 plus 3D. And we know that's equal to 22. And we know the second term is equals to 10 as it is given in the question. This is a very simple system of equations. So 2 minus 1, we have 2d equals to 12, so the common difference equals to 6. And that's your part A. For part B, find an expression for the nth term. Since we know that the second term is equal to the first term plus the common difference, which equals to 10, and from part A we know that d equals to 6, so this means that the first term is simply 10 minus 6, which equals to 4. And now we have all the info required. So the nth term basically equals to the first term, which is 4, plus n minus 1 times common difference, d, which is 6 in this case. And you feel free to expand and simplify this, which leaves us 6n minus 2 at the very end. And that's question 1 complete. Alright, let's move on to question 2. So clear rolls a 6-sided die 16 times. The score obtained are shown in the following frequency table. So you can see all the scores in the frequency. It is given that the mean score is 3. So part A asks us to find the value of P and the value of Q. So for this question, what we can do first is to add another column to this table here, and then do the score times frequency. So x times f. X is a score and f is a frequency. So the first row will be P, second one will be 2Q, this one will be 12, next one is 8, this one's 0, and then this one's 18. Okay, so let's move on to the actual stuff. So for part A, the total frequency, so we just add all of these up. We know that this equals to P plus Q plus 4 plus 2 plus 3, which equals to P plus Q plus 9, and it is given that it equals to 16 here because this die is rolled 16 times. So that's our first equation, which is this one. Oh. Okay, this one. And then, given that the mean score is 3, what we can do is basically add up x times f, and then divide it by 16, which will give us a value of 3. This means we can set up the equation as P plus 2Q plus 12 plus 8 plus 0 and then plus 18 divided by 16, total number of times that the dice was rolled. This gives us a mean of 3. This simplifies down to P plus 2Q equals to 10 if you do the math correctly. And that's our second equation. So we have equation 1 and equation 2, and once again simple system of equations. So we do 2 minus 1. This gives us Q equals to 3, and then P equals to 4. Alright, part B asks, write down the mean final score if each of clear scores multiplied by 10 in order to determine the final score for the game. So when all the scores is multiplied by 10, the mean will also be multiplied by 10, same as for the medium and the mode. So the answer is simply, so nu equals to 3 times 10, which equals to 30. So the mean final score will be 30 points. Alright, and that's question 2 here done. Let's move on to question 3. So a question involving logs. So it is given that log base 10a equals to 1 over 3, where a is greater than 0. So part A asks us to find the value of log base 10 of 1 over a. So we can simply write this as a to the power negative 1, and by the logarithmic rules, we can bring this exponent down to the front. Negative log base 10a, which give us negative 1 over 3. That's part A. Part B asks us to find log base 1000 of a. So here we can use the change of base formula to change everything to base 10. So log base 10a, and then log base 10 1000. Rewrite this in a way that looks a little simpler would be log base 10 of 10 to the power 3. And we know that this part just equals to 3 because log base 10 of 10 is 1, and then when you bring the exponent to the front, 3 times 1 is 3. So this gives us the final answer of 1 over 3 divided by 3, which is 1 over 9. Okay. So for log questions, there's also another formula that you can remember, but it's not on a formula sheet, but it's also very helpful some of the times, which is that the log base a to the power m of b equals to 1 over m log base a b. This is helpful some of the times because saves you a bit of time. And that's it for question number 3. Okay, now I'll pass this on to Alan, and he will explain questions 4 to 6 of section A.
Okay, hello. So, if I were to be completely honest, this is my first time seeing this problem. But that means that I will be employing a lot of the strategies that you can use on the actual exam. And then so, since this is my first time reading this problem, I see that we have this sector of a circle, and then we see that we're given 2 pieces of information. So the first one says that the perimeter of this sector is 10 centimeters, and the area of the sector is 6.25 centimeters, or squared. So now, first part, we're basically asked to show that 4r squared minus 20r plus 25 equals 0. So what I'm going to do is I'm going to use the first bit of information, which tells us that the perimeter of the sector is indeed 10 centimeters. So let's get started. Let's try to write an equation that describes the perimeter of the sector. So first off, if in terms of perimeter, that is basically saying this region right here, or actually I'll make the line a little bit bolder. Oh, there's that one, my bad. Okay, so it's gonna be like this area right here plus these 2 lengths. Okay, that's gonna be our perimeter. So what that'll look like in terms of math, we have part A, and then so we have this first length right here, which is r, plus r for the second length, and then for this arc region, we're gonna do essentially the circumference, which is 2 pi r, and then this is not gonna be the full circumference, it's just gonna be the area that's kind of subtended by this angle. So in terms of how that will look like, okay, so basically okay, so this is going to be theta over 2 pi. So that's the angle that it kind of subtends. And then, so now we can simplify this a little bit further. This equals 2r plus, and then these 2 pi's cancel out. So we're just left with theta times r. Okay, great. And then so now we're given all of this equals 10. And right now we're kind of in a little bit of a predicament because we don't know what theta is. So we can look at the area formula and see how that's gonna work out. Let's see. So we're gonna look at this area of this sector. So we have, where does this come from? Oh, okay. So basically, if you look at the area of the sector, it's gonna be 1 over 2 times r, which is 1 leg, and then times r, and then times theta. So this is going to be equal to 1 over 2 r theta, which equals 25. How is it 25? Where does 25 go from? Okay, this apparently equals 25. So theta equals 25 over 2r squared. Now we're going to plot this straight onto the left side. So this equals 3r, or sorry, this is not equal to 3r. Oh boy, this is equal to 2r plus, and then 25 over r, just like so. And then this all equals to 10. And then so we can multiply both sides by r. So 2r squared plus 25 equals 10r. Oh, there's a 2 here, my bad. Okay, so this is actually, this is, sorry, my bad, guys. So this is actually going to be, so 2r plus 25 over, just like so, equals 10. We're going to multiply both sides by 2r, of course. And then so we get that 4r squared plus 25 equals 20r. Or 4r squared, just like so. And then 4 squared minus 20r plus 25 equals 0. Great. So sorry about the hassle. Now, for part B, it tells us hence or otherwise, find the value of r and the value of theta. So hence or otherwise just tells you to hint. You can try to use the previous part of the problem to answer your problem. So what you can do is, I'm going to try to solve for r, this quadratic here. What I can notice is I can factor this into, I actually cannot factor this. Oh, actually I can factor this. So this is actually 2r minus 5 squared equals 0. So then r equals 5 over 2. Great. And now we just solve for the value of theta by plugging it into the formula. So theta equals 25 over 2r squared. Okay. And then this equals 25 over, and then 2 times 25 over 4. And then so we get that this is all equal to 2. Great. And then just box your answers for good reference. And we are done. So great work. Let's see what else. All right, so here it says centimeters. So just make sure that whenever we write this, we include the units as well. So this right here would be in centimeters. And then as for theta, this I believe is in radians. So you could also, if you want to be thorough, write rad just like so, and then close it off. Great. So now we're going to move on to question 5. It says, consider the functions f of x equals cosine x and g of x equals sine 2x, and we're given this domain from 0 to pi. The graph of f intersects the graph of g at the point A, the point B, and the point C as shown. Great. So before we even get started in this problem, we can notice that this diagram does not actually label which function is which. So if you have no idea which function is which, you can just look at the point where it reaches the y-axis. So if you don't already know that cosine is like cosine 0 is 1, right? So we know this has to be the cosine function, and this has to be the sine 2x function. Great. So now we are to find the x-coordinate of point A and x-coordinate of point C. So we can notice that both of these are intersection points. So all we have to do is just set both of these equations equal. Great. So in part A, we have sine 2x equals cosine of x. Great. So now it doesn't look like this can be solved pretty easily, and keep in mind you have no calculator for the paper 1, so we're going to try to use some trig identities. So if my memory is correct from the formula sheet, sine 2x equals 2 sine x cosine x equals cosine x, just like so. And now we're going to move all the cosines to one side, so we're going to do cosine x, and then 2 sine x minus 1 equals 0. Great. So if you remember how you solved your factors for polynomials back in the day, you can notice that either this part is equal to 0 or the second part equal to 0. Okay. So first case is cosine x equals 0. This gives us x equals pi this equals pi over and 3 pi over 2. Okay, great. And we also have 2 sine x minus 1 equals 0, or in other words, sine x equals 1 over 2. And then so we can also solve that. So we can keep in mind CAS rule. This would be pi over 6 and CAST. So pi over 6. Great. Okay, so we have these two values for x that could be possible. So okay, so and then if we look closely, if we look back up at this diagram right here, so this is pi over 2. This equation right here, or this solution right here, 3 pi over 2, is actually outside our domain. And then on the left and right side, we have pi over 6 and 5 pi over 6. So this one would have an x-coordinate of pi over 6. This one would have the 5 pi over 6. And the question asks us to find the x-coordinates, so you would just basically represent like so. So A would have an x-coordinate of x equals pi over 6. And then C would have x equals 5 pi over 6. Great, and then just box our answer just like so. And then for part B, it says find the area of R. So now we're going to have to use some calculus skills. We're going to have to use the integral to find the area. And we see the top curve is going to be our cosine x function, which is right here. And then our bottom curve is going to be the sine 2x function right here. So in order to do that, we're going to take the area, so area equals, and then we're going to take the integral from essentially the endpoints which are B and C. So the endpoint is 5 over 6 for the C, and then on our left we have pi over 2, which is B. Okay, and then now we're going to take the top curve and subtract it by the bottom curve. So we have cosine x minus sine 2x. Okay, and then with respect to x, now it's just a matter of integrating this function. So the integral of cosine x, as you know, is sine x. Okay, and then if you don't know the integral of sine 2x, actually you would know the integral of sine 2x, it would be plus 1 over 2 cosine of 2x, just like so. And then you want to evaluate this on the bounds 5 pi over 6 and pi over 2. Okay, so you would solve this. It would be sine 5 pi over 6 plus 1 over 2 cosine 5 pi over 3. And then you would subtract sine pi over 2. And then you would add back 1 over 2 cosine pi over 2. And then if you simplify all of this, hopefully this is equal to 1 over 4, which should be our final answer. And of course it asks for area, so we just want to include units of units squared, just like so. Great. So this is our answer for question number 5. Now we're going to move on to question number 6. So consider a geometric sequence with first terms which is equal to 1 and the common ratio 10. So we can notice that first it tells us to find an expression for the sum in the form of a to the power of n minus 1 over b, where these are like unspecified integers. So we can recall the sum of a geometric series formula. So if we go to the formula booklet and we scroll down into the geometric section, we have the sum of n terms of a finite geometric sequence, and this is going to be the formula we can use. So if we go back here, we're going to take the first term, so just write this as sum equals, first term is 1, and then r to the power of n, so our common ratio is 10 to the power of n, minus 1 over, and then you take the ratio minus 1. Okay, and then you can simplify this a little bit further, so this will become 10 to the n minus 1, so just like so, 10 to the n minus 1 over 9. And we can verify that this follows the solution because it wants this and this to be integers, which we have. So this is going to be our final solution. Great. Now for part B, it asks us to hence show that the sum from S1 to Sn is going to be 10 times 10 to the n minus 1 minus 9 over 81. So we can rewrite the sum a little bit differently. So we can write this in terms of 1 over 9 and then 10 to the n and then minus 1 over 9. So if you look at this question really carefully, it's basically telling you to add the sums up, okay? So not the individual terms, but the sums that we got from part A. And then so we find that, so the sum is equal to this 1 over 9 times 10 to the n minus 1 over 9, like so. I can do it, okay. And then, now we just want to see that this is going to be geometric. And then this is going to be essentially, well, like arithmetic or geometric, but the common ratio is either going to be 1 or the common difference is basically 0. So if we're to add multiple forms of this, the first term of this geometric sequence, starting with 10 to the 1, would be 10 over 9. So now we just use the formula, so sum equals 10 over 9, which is our first term, and then times the ratio, which is 10 to the n minus 1, all over the ratio minus 1 as before, so 10 minus 1. And then you would also add this part, the second part. So we just do 1 over 9 times n, because that's like the amount of times you're essentially adding that negative 1 over 9 term. And then now you just want to put it all under this fraction, so it looks something like this. So we can see, we can bring this over 9 to the bottom. So we get 10 times 10 to the n minus 1 over 81, and then we have n over 9 here. Now we just want to bring this chunk into the left fraction. So then this would all be equal to 10 times 10n minus 1 minus 9n over 81. And that's our final solution. Great. And so now we've shown that this equation holds true. And for these types of questions, we just have to make sure that if it says hence, we have to use the formula from part 1. So I could have been a little bit more clear by saying this equals to the previous sum formula that we got in part A, and this should be good for this question. Okay, great. Now we're going to move on to question 7, which is section B. But first, we're going to take a quick 5-minute break so you can catch up and you can try some of these problems for yourself.
Okay, hi guys, welcome back. Now we'll move on to section B of this paper. First question, consider the curve with equation y equals to x to the power 3 minus x squared minus x plus 1. So part A, I find dy over dx. Basically, derive this equation y here once, which will give us 3x squared minus 2x minus 1, because you bring the exponent down and then you subtract 1 from the exponent. So now you want to find the second derivative for part I, which basically means you can derive the first derivative again. This gives us 6x minus 2. And that's it for part A. Okay, so part B says the curve has a local maximum at A. Find the coordinates of A and use an answer to part I to justify your answer. So we'll write part B down here. So on the official exam, you'll be given a separate answer booklet for you to record all of your answers. Here I'm writing it here just so it's easier to see. Okay, but make sure on the actual exam, don't write it on here, they won't mark it. You have to write it in the official answer booklet provided separately. Okay, so to find the local maximum, all you need to do is set the first derivative to 0 and solve for x. So 3x squared minus 2x minus 1 equals to 0. Factor this through 3x plus 1, x minus 1 equals to 0, x equals to negative 1 over 3 and 1. So we have two answers here. So this probably implies that one of them would be a local maximum and the other one would be a local minimum. So now we just need to decide which one is which. There are two methods of determining the local maximum. Either one works, depends on your preference. The first method will be we do a sign chart. Just going to quickly draw the chart here. So we have 3x plus 1, x minus 1, and then dy dx. Oops, that's a little weird. Okay, and then now we can put in the values we got when we solve for x. Negative 1 over 3 and 1. So here this one will be negative and then positive and then positive and then negative, negative, positive. Negative times negative is positive, positive times negative is negative, and positive times positive is also positive. So this means that at x equals to negative 1 over 3, the function is first increasing and then decreasing. And at x equals to 1, the function is decreasing first and then increasing. And here we can see that obviously the first one will be a local maximum because it has a maximum point here instead of having a minimum point somewhere. So this means that the max is at x equals negative 1 over 3. And it asks us to find the coordinates of A, not just the x value of A. This means we have to plug in this x value back to the original equation to get the y value. Make sure here you plug it into the original equation, not this equation, because if you plug it into the first derivative, it will give you a value of 0, which is not actually the y coordinate of this point A. So plug in x equals negative 1 over 3 back into the equation for y. We have y equals to negative 1 over 3 to the power of 3, and then minus negative 1 over 3 to the power of 2, minus negative 1 over 3, and then plus 1. Making this a little smaller. So then we have equals to negative 1 over 27 minus 1 over 9 and then plus 1 over 3 plus 1. And then here make sure you add up all the fractions right, and you should get an answer of 32 over 27. Here please make sure you don't make any small mistakes when you do the addition or just the orders of operations, because you definitely do lose points, 1 point if you make a mistake here, and it's not worth it to lose a point on those small mistakes. Okay, and in option 2, we have to find the local maximum would be to use the second derivative test. What you can do here is basically find the value of the second derivative at these 2 points. So at x equals -1/3, the f prime double prime of x would be smaller than 0, which means this entire thing is concaving down, which thus proves that there is a local maximum at this point A. And -1/3, and then f double prime at 1 is greater than 0 because we have the equation here. You plug in 1, 6 minus 2 is 4 greater than 0, which means it's concaving up. Okay, so you can choose either method depending on which one you like more or is more familiar with. So we have the final answer here, which is A is at -1/3 and then 32/27. That's part B of this question. Alright, so part C says the curve has a point of inflection at B, and then find the x-coordinate of B. So from part A, we know that the second derivative is equals to 6x minus 2. So in order to find the point of inflection, we set this equals to 0. Solving for x, we get x equals to 1/3. And well, that's it. All you need to find the x-coordinate, and there's nothing to justify or anything. Alright, part D. So the line L is normal to the curve at the point 0, 1, and it asks you to find the equation of L. So the normal line passes through 0, 1. So we'll just have the point here. Write it down here so it's easier for us. So we know that the first derivative gives the slope at any point x, and from part A we know that it equals to 3x squared minus 2x minus 1. So we want to first find the slope of the tangent line at x equals to 0. So at x equals to 0, f prime of 0 equals to -1. This means that on the function y, when x equals to 0, the slope of the tangent line is -1. But here we're asked to find the equation of the normal line, and we know that the slope of the tangent line times the slope of the normal line equals -1 because they are perpendicular to each other, and the slopes are the negative reciprocals of each other. So this means that the m normal would be equals to 1 because -1 times -1 over -1 is 1. And we're given this point, so we'll use it to find the final equation. Y minus 1 equals to 1 times x minus 0, and this simply gives us y equals to x plus 1, and that's your final answer here. Alright, that is all for the first question, section B. This question is worth 14 marks, so make sure you know how to do all the questions, all the parts, and that's some calculus. Alright, let's move on to question 8, which is the second question in this section B. Okay, so it says, consider the function f of x equals to 4x plus 2 over x minus 2, where x cannot be equal to 2. So part A says, sketch the graph of y equals to f of x. On your sketch, indicate the values of any axis intercepts and label any asymptotes with their equations. So we have part A down here. F of x equals to 4x plus 2 over x minus 2. So first we draw the axes, draw a grid for your graph. I like to label x and y so it's more clear. Okay, so looking at this graph, we know that the bottom cannot equal to 2. This means that it has the vertical asymptote at x equals to 2. And we see that the top and bottom are both like 1 degree polynomial functions. So the horizontal asymptote will simply be the leading coefficient over the leading coefficient. So the horizontal asymptote is at y equals to 4. Right, so now we want to like actually draw the asymptotes on the graph here. So this one is x equals to 2, and then this one is y equals to 4. So this function will look like this. So here, if you're not sure like where to put things, you feel free to test a few values on the graph so you're sure of where to draw your function. Okay, and this question also says label any x-intercepts. So we need to label the x and y intercepts. So for the x-intercept, we have y equals to 0. So simply be 4x plus 2 equals to 0. So x equals to -1/2. And when x equals to -1/2, the y value should be, the y value should be, if you plugged it into the equation, the y value should be 0. My bad. And then for the y-intercept, we set x equals to 0. So 4 times 0 plus 2 over 0 minus 2, so we get -1. Okay, and here the x is 0. So this gives us that one of the intercepts is at -1/2, 0. The other one is at 0, -1. So we just label them here. 0, -1. This function should actually be moved down a little bit. Like this. Okay. So we have 0, 0, -1, and then -1/2, 0 here. Okay, so that's part A of this question, which is with your labeled graph. Okay, let's move on to part B of this question. Part B asks us, write down the range of f. So for the range here, we know that since there is a horizontal asymptote, the y value will never equal to that value, which equals to 4. So the range is so y cannot equal to 4, and y otherwise y can be any value in the real number set. Okay, for part C, it says consider a function g of x equals to x squared plus bx plus c, and the graph of g has an axis of symmetry at x equals to 2. The two roots of g of x equals to 0 are -1/2 and p, where p is a rational number. So C says show that p equals to 9/2. Okay, so we know that the function of a quadratic, if we sketch it out on the graph, it will look something like this. This says it has an axis of symmetry at x equals to 2, so technically we should move it to the right a little bit. So symmetry x equals to 2. Okay, so this means that for any points on the right or on the left side of the line x equals to 2, that as long as they're the same distance from the line, they will also have the same y value. So what we can do here is that the question says show that p equals to 9/2. We know that g of x equals 0 are -1/2 and p. So this means that one of one of the points, one of the x-intercepts, it's not 0, 0. Looks a little weird. This one, we will label this one as negative 1 over 2, 0. And at this point, we can just call it P0. So, now we know that P plus Q over 2 equals to X. And so P plus negative 1 over 2 over 2 equals to 2. This gives us P equals to 9 over 2, which is what was required. This is because, the same distance from negative 1 over 2 to X equals to 2, and then also same distance from X equals to 2 to P. So the same distance. All right, so that's what we have for part C. Okay, so for part D, find the value of B and the value of C. Okay, since we know that from part C, the two x-intercepts are at x x-intercepts are at x equals to negative 1 over 2 and 9 over 2. So we can basically use, there's various ways we can do this. This means that x, so if we set this equals to, wait, how do I explain this? Okay, so we can use Vieta's theorem from Math 20. So x1, so in x1 times x2 equals negative b over a, and then x1 plus x2 equals to c over a. So this means that negative 1 over 2 times 9 over 2 equals to negative b over a. So negative 9 over 4 equals to negative b over a. 9 over 4 equals to b over a. And x1 plus x2 equals to c over a. So negative 1 over 2 plus 9 over 2 equals to c over a. This basically means 4 equals to c over a. Okay, so here what we can do is so 9a equals to 4b, and then 4a equals to c. Okay, actually, okay, here what we could do is, okay, actually guys, this method not very valid because we have 3 variables and 2 equations only. So so don't follow what I just did. Okay, we can ignore that section. Okay, and then we can just do g of x minus negative 1 over 2, and then x minus 9 over 2. So okay, so we know that these because these two we have these 2 roots, therefore the 2 factors of g of x must be these. Okay, so x plus 1 over 2 times x minus 9 over 2. And then we expand this and simplify this. X squared minus 9 over 2x plus 1 over 2x minus 9 over 4 equals 2x squared minus 4x minus 9 over 4. Okay, so b equals to negative 4 and c equals negative 9 over 4. And that's our answer for this question. Okay. Part E. Find the y-coordinate of the vertex of the graph y equals to g of x. Okay, so in order to find the coordinate of the vertex from part D, you already found the equation of g of x. So g of x equals to x squared minus 4x minus 9 over 4. So here, in order to find the y-coordinate, we want to have x equals to 2. So g of 2 equals to 2 to the power 2 minus 4 times 2 minus 9 over 4. And this will give us 4 minus 8 minus 9 over 4, which equals negative 25 over 4. Alright, let's move on to F. Find the number of solutions of the equation f of x equals to g of x. So from the question, we know that f of x equals to 4x plus 2 over x minus 2. And then g of x from part D, we know that g of x equals to x squared minus 4x minus 9 over 4. So to set them equal to each other, 4x plus 2 over x minus 2 equals to x squared minus 4x minus 9 over 4. Okay, so looking at this, it will be a lot of work if you want to actually algebraically determine what x is, or the intercepts for these two functions are. However, there is a quicker method in which we can do this, because all the questions asked is find the number of solutions of the equation, not what the exact solutions are. So what we can do is to use the graph from part A, and also, actually draw out g of x on that same graph again. So if I just copy and paste this onto the page we were on earlier. Okay, here. So since we already know what the x and y intercepts of g of x are from the previous questions, all we're gonna do is just label it, or draw this graph on the same grid, which will look like something like this. So here we see that there are 1, 2, 3 intercepts between our f of x and g of x. This means that n equals to 3, as what the question asks. Okay, there are 3 solutions, if you want to make it more clear. Alright, and that's it for question number 8. Now we'll move on to question number 9, and I will pass it to Alan.
Okay, so now question number 9 is going to be the last problem on your paper 1. And we see that in terms of weighting, this has pretty much the highest amounts of marks awarded. So you want to be extra careful in all of your steps and to read the question very, very carefully. So since there's quite a lot of text, I'm not going to read it aloud. But essentially, we're going to jump straight into part A. So part A tells us to find the value of P and the value of Q. So if we look very closely at this diagram that they show us, essentially how the game works is you start off with 3 red buttons and then 1 blue button. So this is going to be your starting point. And then what it's saying is, in order to select one red, I believe it's 1 red button at this point, you would have 3 of the 4 possible buttons. They're going to be red, so therefore your chance of picking is going to be 3 over 4. And then same for blue, but instead there's only 1 blue button, right? And then so if we look into the first case just as an example, so this case right here, we can see that after the first button was selected, we have essentially 4 red buttons now, and then of course we keep the 1 blue button, And then so when we select the second button, there's going to be a 4 out of 5 chance to select a red button, and then of course the complement of that, which is 1/5 for the blue button. Now we're going to try to compute this for the other branch. So again, we're going to start off with here, which is 3 red buttons and the 1 blue button. So in this branch right here, we're going to select a blue button first. So what that's going to do is it's going to create 2 blue buttons just like so, and then of course we keep the 3 red buttons. And so after we pick this blue button, in order to get a red button, there's going to be 3 out of the 5 possible. So P here equals 3/5, and then the blue is going to be equal to 2/5. Okay. So of course, when you're answering in the IB exam, you don't want to be answering just like right here. You want to be answering on your answer sheet. So I'm going to go into answer sheet here. We're going to do, we can essentially draw this out. So again, you would have just black as a color, and so you'd have probably just like so. I'm going to start with red, 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 blue, and then after the first move, we're going to get red, 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 blue, and then another blue over here. And then, so this is going to be after first step. And then how this is going to work is now we just have to compute the probabilities for P and Q. So the probability of P, which is getting a red ball, or sorry, not a red ball, but a red button, is going to be 3. So it's desired over total. Just like so. And so it's going to be 3 out of 5. So this is going to be answer your P. And then for Q, sorry, this is going to be actually an equal sign right here. And similarly for Q, it's also going to be desired over total. And this is going to be equal to 2 out of 5. So 2 out of 5. Just as we've shown above. Great. So now for part B, it tells us to show the probability. Okay, so the actual probability should be from 0 to 1. Just like so. And then we want the probability that 2 buttons are selected of the same color and they are 7 out of 10. So what this means is you're either going to select a red button twice or you're going to select a blue button twice. So here we see if we select a red button twice, it's going to be 3/4 times 4 out of 5. That's going to be your red probability. And then, or like have the probability of having 2 reds in a row. And then to have 2 blues in a row, you're going to have 1/4 times Q. So now we're going to apply this math down in our response section. So we're going to create a new part, which is B. And then so the question asks us the probability that Francine selects 2 buttons of the same color. So I would probably just write this as P, selecting same color twice. Okay, and then equals P red, like that's the first time, and then red for the second time, plus P blue, and then blue. Okay, and then we're going to set this equal to, as we've shown above, the first probability for drawing a red button for the first time is 3 out of 4, second time is 4 out of 5, so we can write this as 3/4 times 4/5, and then as we called earlier with the first time drawing a blue button, it's going to be 1/4, the second time is going to be Q, so this would be plus 1/4 times Q. Great, so now we can simplify this a little bit down. So this is going to be 3/5 plus Q/4 equals to the probability that they give us, which is 7 out of 10. Great, now you're going to simplify this like you do any other algebra equation. You're going to look for the least common multiple of the denominators. So we see 5, 4, and 10. LCM is going to be 20. Now we're going to multiply every single fraction by 20. So this implies that, so 3 times 4 is going to be 12, plus q times 5, which is 5q, and then equals 7 times 2, which is 14. This implies q equals 2 over 5. And there we should have our answer, because show the probability that friends, so select the same color is 7 over 10. Oh, wait a minute. I actually flipped the question around. So instead of doing all of this work, all you could just do is, instead of writing this in terms of q right here, you could just write q equals 2 out of 5. And it becomes a lot easier, because once you add these fractions up, it'll be 3 over 5 plus 2 over 20, or essentially 1 over 10. So you get equals 7 over 10, just as required. So that is actually the moral of the story. Please read the question very carefully, because don't do what I just did and waste a little bit of your time. And part B will be done, because you've just shown that the probability is 7 over 10. Okay, so now we're going to go on to part C. Given that two buttons are of the same color, find the probability that there are two red buttons. Great. So if it gives us that there are two buttons of the same color that are selected, that means that either two reds are selected in a row or two blues are selected in a row. So as we shown earlier in part B, the probability that you select two colors that are the same in the first place is 7 over 10. Okay, and so given that this 7 over 10 probability occurs, find the probability that it's actually the two red buttons that's the event that actually occurred. So let's see how this makes sense on paper. The probability that two red happens, the probability that two red buttons are drawn is right here. So it's going to be 3 over 4 times 4 over 5, which we derived as 3 over 5. So the desired case that we want has a 3 over 5 chance of happening. Now, if we want to look at the total, which is the probability that the same color happens, which is going to be P red plus P blue, we derive this in part B, which is 7 over 10. Okay, and so here we can just simplify this as 3 times 10 over 5 times 7, or you can essentially cancel these 5s out and you get 6 over 7. And that is your final answer. Now for part D, we have now what looks like a probability distribution table. So what this is essentially saying is that in order for this case x to be 0, there's a 1 out of 10 chance happening. And then same thing for 1 and 2, except the chances of happening are A and B. Now, when it says the number of red buttons selected by this person is 1, we can compute the probability for A. So the random variable in this case is the number of red buttons selected. So if only one red button is selected, we either go this route right here, so this route, or, so we either go this route right here, or we go this route right here. Okay, so we're going to show both of those on paper using math. I'm going to go into part D just as follows. So the chance of the red happening in the first case is 3 over 4. Then to have the blue is 1 over 5. And then you would add this to 1 over 4, which is getting the blue first. And then you'll want the red afterwards, which is 3 over 5. Okay, and you're going to solve this fraction. So it'll be 3 over 20 plus 3 over 20, which is all equal to 3 over 10. So this should be your value for A, just like so. And then for your value of B, you actually don't need to do all those calculation processes, because you know that the sum of every single probability here is equal to 1. Okay, so you can do this trick where you do b equals 1 minus 1 over 10 minus a, which is equal to 1 minus 4 over 10, which is 3 over 5. Great. Always box your answer, and now we're going to move on to part E. So hence, which means you have to use the results you found before, find the expected number of red buttons selected. So here we have expected number, and I'm not sure if this is actually in the formula booklets. We can actually go check right now. This is HL. Where is statistics? Yep, so expected value, basically what this equation means is for every value that you see in the table, you're gonna write x, which is like the actual value you're getting, so like 0, 1, 2, 3, and then this right here is going to be the probability that it occurs. So this is like the actual like outcome, and this part is the probability. So we're going to go back to the actual paper. What this looks like is we're going to take the sum of each single column. So for the first column, we have the actual number being 0. Chance of it happening is 1 over 10. And then, so if you want to be thorough, this would be E of x, just like so, equals 0 times 1 over 10 plus 1 times A plus 2 times B. Now, of course, when we answer this on the answer sheet, we want to write this out and then substitute the values that we found earlier for A and B. Great. So we're on part E. What we want to do is we want to write the expected value of x. Always communicate what you're solving for. So here I write E and then in brackets x equals 0 times 1 over 10 plus 1 times 3 over 10 plus 2 times 3 over 5. And then now we can just simplify this. This turns to 0. And then what we're left with is 3 over 10 plus 6 over 5. And then this equals 15 over 10, or we can simplify this down to 3 over 2. And that's our final answer. Now, looks like we have 6 marks left to go in this question. Basically, this paragraph says that we have the same process happening, but instead we just keep on going until we find a blue button. So, question F tells us that given the first 2 buttons she selects are red, write down the probability that the next button she selects is blue. So, we first want to calculate, of course, the probability of first 2 buttons being red. So if we look back at the diagram here, it's going to be 3 over 4 times 4 over 5, which we calculated over here, P equals 3 over 5. We're going to use this for parts F. Okay, and then now we want to write down the probability that the next button she selects is blue. So we're going to go through the same kind of game theory stuff going on right here, but with the F subparts. So we've already started with this case where we've selected 2 reds in a row. That means that first off we started with 3. By the first turn we had 4, and by the second turn now we have 5 reds and 1 blue button. So we're just gonna quickly draw that out like so. Red, 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 and just 1 blue. Okay. Now, it's asking for the chance that this is going to be the time where we select a blue button. So, given this happening, there's a 1 blue button out of 6 total. So 1 over 6 is the probability of the blue happening. So of course, we want to communicate this because we want to show all work. So probability of blue, in this case, is equal to 1 over 6. And then afterwards, we would take 1 over 6 times the probability of even getting to this case in the first place. So we derived this earlier as being P equals 3 over 5. Now we just do probability desired. So probability of blue so selecting a blue button, given, which is this symbol, that we've had red and a second red, is equal to 1 over 6 times, and the chance of even getting to this case in the first place, which is 3 over 5, and our answer. Oh, never mind, sorry. I may have misread the question a little bit. So the question is actually just asking if we've already given the first two are red, so we don't have to care about if they're not. So all we have to do is just say the probability of blue happening here is just 1 over 6. Great, so just make sure when you read the questions, don't make the same mistake as I just did. Now for part G, we have probability she selects the first blue button after n selections in total is 3 over 56. So this means that we have n minus 1 selections that are all red, and then on the nth selection we get a blue. How does this work mathematically? Let's see. So in order to select a red every single time, first off, remember we started with 3 reds and then 1 blue right here. So if we started with 3 reds and 1 blue, the first turn when you get a red, it would be, let's say, 3 over 4, which is your chance. Afterwards, the second time would be 4 over 5, and then after it'd be 5 over 6, and then so on, right? Up until some number, which is essentially, if you follow this pattern, it's probably going to be, let's see, 4 plus 1, so 4 plus n minus 1, so this would be just like so. How I did this was essentially, this would be the first turn, this is second turn. You would have n minus 1 turns here, and so you would take, oh no, sorry, this is actually going to be n minus n plus 1 like so, and then n plus 2. So what we do to calculate this is we essentially take whatever we have on the turn number, and we just add 3, and that's kind of like a pattern we expanded on. But if you were to vigorously show this, you would have to show something with like induction, but we don't need to do this on the exam. So we have all of this product being equal to 3 over 56, and then we can notice that all of these diagonal terms cancel out like so, okay? And essentially the denominator of one term cancels with the numerator on the next. So all we're left with is 3 over n plus 2 equals 3 over 56. And then we can just look at the denominators and compare them. This implies that n plus 2 equals 56. Oh, minor error. So this also implies that on the nth turn we have 1 over n at the very end, just like so, and it equals 3 over 56. Why I forgot to add the 1 over n earlier is because this accounts for the case where we select one blue ball, or sorry, not one blue ball, one blue button after like n, essentially after n, oh shoot, this is also what, n plus 3, sorry, my bad, this is n plus 3 over here after essentially n turns. And then now we're going to simplify this fraction as we shown earlier. So 3 over n plus 2 times n plus 3 equals 3 over 56, which implies that n plus 2 times n plus 3 equals 56. And then what you could do is you could basically turn this, well, you can first of all think of the factors like 7 times 8 equals 56. But of course you want to be more vigorous on the actual exam. So what you could do is you could write n squared plus 5n and then minus 50 equals 0. And then what we're left with is we can factor this equation right here. So this implies that n plus 10 and then n minus 5 equals 0. And of course, if n was negative, you cannot have negative terms. Therefore, n equals 5. And essentially, I think that's it for this question. This means that we've taken 5 turns and our total probability is 3/56, just as required. So hopefully this will net us 5 points, and this is the end of the question. Great. So in terms of how statistics go, this is pretty much the length of application you're going to get. First, we kind of applied a little bit of Bayes' theorem in this like part A, B, C. And then on part D and E, we used like expected value, and then F and G was just a little bit of algebraic manipulation. Okay, great. So now we're gonna move on to paper 2 after a quick 10-minute break. So please, during this time, you can try to practice some of the problems yourself, and we'll be back in 10 minutes.
Hey guys, welcome back. Now we'll move on to paper 2 of May 2024. So once again, we'll briefly look at the instructions. Same as paper 1, you have an hour and a half to complete this paper. And here you are allowed a calculator and it is required. And please, you use a calculator because if you don't, you can't do this paper. And then, just as before, you have the SL formula booklet, and the maximum mark for this paper is also 80 marks. Alright, let's move on to the actual problems. Section A, question 1. So, Janie claims that rabbits in Australia have longer ears than rabbits in Spain. To test her claim, a randomly selected sample of rabbits was collected in each country. The length of one ear of each rabbit was measured and the value recorded correct to the nearest millimeter. In the Australian sample, the median recorded value was 80 millimeters and the interquartile range was 11 millimeters. So as you see in the box and whisker plot, you have the recorded values for the Spanish samples. So part A asks, complete the following table for the recorded values of the length of the rabbit's ear in both countries. So for Australia, it was given, and for Spain, we have to use this box and whisker plot provided above. So basically, the median is just the middle value, which is here. I'll highlight this. So the squiggly line should be 2. This is at the middle here, which means that the median for Spain is 75, because this line in the middle is 75. Oops, 75. And for the interquartile range, all you're going to do is just subtract the first quartile from the third quartile. So here the third quartile is at 84, and then the first quartile is at 68. All you're going to do is 84 minus 68, which equals to 16. And that's our answers for part A. If you want to make it more clear, you can write it again down here. So A, we have 75, and then 16 as the two answers we filled in the table. Okay, let's look at part B. Justifying your answers, compare the distributions of the length of rabbit ears in Australia and Spain using I, the median, and I, the interquartile range. So, part B. So, for I, so we see that Australia has a higher central tendency because its median is larger than Spain's median. Australia has a median of 80 and Spain has a median of 75. So a higher median means a higher central tendency. So all I'm going to write down here is that Australia has higher central tendency because it has a higher median. And this is also part of the definitions you need to know for median, so don't forget that. Okay, for BII, so for the interquartile range, we can compare the values here. For Australia, there's 11, and for Spain, it's 16. Because the interquartile range for Spain is larger, this means that there's more variability in the middle 50%, so from Q1 to Q3 of the data, just because compared to Australia, it does have a larger IQR. So all you're going to write down here is Spain, I'm not going to write down the full country name, just actually write down the full names on your exam. So Spain has more variability in the middle 50% because it has a larger IQ interquartile range. And that's all you need to justify for part B. 2 marks for I and 2 marks for II. Okay, alright, and then that's it for the first question, just parts A and B. Now let's move on to the second question, which is something about exponential growth and decay. So the question says Darren buys a car for $35,000. The value of the car decreases by 15% in the first year. So part A asks you to find the value of the car at the end of the first year. So this here, I recommend you just put it in your calculator. So value of the car at the end of the first year equals to, so value equals to 35000 times 1 minus 15% to the power of 1. So this is 35000 times 0.85, which gives us a value of 29750. And put this in your calculator and make sure you don't enter anything wrong, or else that'd be very sad. So because this is a word problem, so don't forget to put your dollar sign, or you can put dollars at the end, up to you. Okay, and that's part A. Part B, find the value of Darren's car 10 years after he buys it, given your answer to the nearest dollar. So this we can use the concept of geometric series. We know that u1, which is the first term in this series, is equals 29750 from part A. And then we know the common ratio R is 0.85 because that's the rate of decay for the price of this car. And now what we're asking is what is U10, so the 10th term. How we can do this is U10 equals to first term, so 29750 plus 10 minus 1, which is 9, and then times 0.85. Plug this into your calculator, and the value you get should be 10423.103 or something. So here, because the question does ask you to give your answer to the nearest dollar, you just leave the answer like this, and then make sure to add dollar signs before, so it's a unit. Okay. And part C says, when Darren has owned the car for n complete years, the value of the car is less than 10% of its original value. And C, find the least value of n. Okay, so we can set up a kind of equation here. So 0.1 times 35000 equals to 29750 times 0.85 to the power of n. Actually, guys, I made a small mistake here. This one is 0.89 instead, and for part B is also 0.89 because it actually decreased by 11% instead of 15% in the first year, so that's a little different. My bad. And then here it should be 0.89 instead of 0.85 because after the first year, the value of the car decreases by 11%. Okay, so here you would, do a bit of lots, and then solving for n in this equation, you get n equals to 19.364 something years. And because it says to find the least value of n, and it has to be a complete year, and we'll round n up to 20, so n equals 20 years. This one you cannot round it down to 19 because at n equals 19, this value of car actually has not yet been less than 10% of its original value. So you always have to round it up when it comes to these questions. And make sure to read the question carefully and don't be like me, accidentally putting the wrong values. All right, and that's it for question number 2. Let's move on to question number 3. Trigonometry. Okay, so a monument is in the shape of a right cone with a vertical height of 20 meters. So this is from here to here, 20 meters. Oliver stands 5 meters from the base of the monument. So this is Oliver here, and then he's 5 meters from the base of the monument. His eye level is 1.8 meters above the ground, and the angle of elevation from Oliver's eyes to the vertex of the cone is 58 degrees, as shown in the diagram you can see here. So from here to here, 58 degrees. So question A asks us to find the radius of the base of the cone. So what we can do here is consider this triangle over here. Okay. We know that we can find the length of this by subtracting 1.8 from 20. So this is 20 minus 1.8, which equals 18.2 meters. And we actually don't know this length here, we'll just call it A. So, and we can just use tangent. So the tangent of 58 degrees equals to opposite over adjacent. So 18.2 over A equals to 18.2 over tangent 58 degrees. And put this in your calculator, we get that A equals to 11.3726 ... However, we were asked to find the radius of the base of the cone, not the distance from the center of the cone to the person, so we actually have to subtract the 5 meters from A to get the radius. So A minus 5 is the radius. So 11.3726 minus 5. So we get a radius of 6.37 meters. And make sure that you have to round this to 3 sig digs, because in the instructions over here, above here, it does tell you that your answer should be given as exact values or correct to 3 sig digs. So make sure that unless the question specifies how many sig digs you should have, make sure to always either give us as an exact value or put in 3 sig digs. Alright, and that's a final answer for part A. Okay, now let's move on to part B. Find the volume of the monument. This one is just plugging into equation. We know that the volume of a cone is V equals to 1 over 3 pi r squared h. And then we know what r is, we know what h is. So r is 6.37 from part A, and then h is 20 meters, which is actually given in the question. Plugging this in, 1 over 3 pi, and then times 6.37 squared times h, which is 20. And this should give you a final answer of 851 meter cubed. And make sure you have to include the units, because this is a word problem and you must have units. Okay, and that is it for question 3. Requires a bit of trick and mostly plugging into your calculator. Okay, now I'll pass this over to Alan, who will explain questions 4 to 6.
Okay, so we are now on question number 4, which states that the variable x, which is random, is normally distributed with mean 10 and standard deviation 2. So we can basically find the probability that x is more than 1.5 standard deviations above the mean. So what this is essentially saying is that our mean is 10 and our standard deviation is 2. So if we have a TI calculator, first of all, 1.5 standard deviations above the mean is going to be 10 plus 2 times 1.5, which is equal to 13. And then so in our calculator, we could go into, or at least on TI, you could go into, I believe, second vars, which gives us distribution. We'll do normal CDF, which is our cumulative distribution function. Our lower bound would be 13. Our upper bound would be 10 to the power of 99. Our mean would be 10, and our standard deviation is our standard deviation is 2. And then now we're going to solve this into a calculator, and then we're going to get the value. So let's say probability, just like so. Or actually, to be even more concise on the exam, you could just do p, and then let's say x, which is our variable, is greater than 13, is equal to, and then our function that we use on our calculator. So on the TI-84, this would be normal CDF, and then we put the values that we used, so 10 to the 99, 10, and 2, which gives you 0.0668, which is rounded to 3 sig digs. This is going to be our answer for part A. Now for part B, it's telling us to find the probability that x is more than k standard deviations above the mean, and it gives us that this value is 0.1. So if you remember from previous lessons, from yesterday's lesson, we could use the inv-norm function, which is basically you can have we know the area under the curve, we know how many people are, let's say, to the left or to the right of this value, and all we need to find is the precise value that you're looking at. So we're given essentially by the problem that P, so the probability that x is greater than k times k times 2, which is our standard deviation. So 2k, or actually it would be 10 plus 2k because that's the actual value that we're doing. 10 plus 2k, and this is going to be equal to 0.1. So then we can use the function our calculator. So 10 plus 2k equals inv-norm, just like so. And then we can go into second distribution, go into inv-norm. So our area we are given is 0.1, the mean is above, which is 10, the standard deviation is 2, and then we want to make sure that our tail is to the right. So if we look at this distribution right here, so something that looks like this, let's say this is a specific point we're looking at. What the area we want right now is like this chunk right here. This is the area. And as you can see, tail basically means like which area you're looking for. And we see this is to the right of this particular value. Okay, so our tail should be right. We're going to write 0.1, 10, to right. And then this is equal to, paste this, 12.56 or 23 sig digs, 12.6. And that's our final answer for question number 4. All we have to do is remember to use your normal CDF function and your inv-norm function. Without your calculator, you cannot actually compute this like really easily. In fact, it's probably next to impossible at this level. So remember to know how to use these functions on your calculator, and when it prompts you to do stuff with distribution, so when you see words like distributed, like random variable is also typically one term that goes with it, but not always. When you see these two together, typically they're saying use your calculator and then see how these values work out. So for number 5, we have a difficult situation. It looks like we have some kind of kinematics problem. So we have this particle and its velocity is modeled by 2 sine 0.5 t plus 0.3 t minus 2, and the domain is from 0 seconds to 10 seconds. First off, for part A, it tells us to find the smallest value of t when the particle changes direction. So I'm just going to do this really quickly. When it changes direction, it just means the velocity changes sign. So for example, if velocity is negative and it suddenly turns positive, then the particle must change direction. That means that we're going to look for these points right here, but it says the smallest value of t. So for part A, we want to look at this value right here. In order to do so, we're going to look at the equation. So v equals 2 sine of, let's see, v equals 2 sine of 0.5 t plus 0.3 t minus 2, and then we want to set that equal to 0 because that's where it's going to change sign, hopefully. And we're going to essentially, what we could do is we can solve all this with a calculator by graphing it. I think that's probably the best option in this scenario, because eventually if we were to algebraically solve this, we're going to be left with a sine with a t term, we're going to be left with some kind of polynomial t, and so that's going to be really hard to deal with. Instead, I'm going to use my calculator, and then I'm going to go into my graphing section. I'm going to put this exact function into there, 3x minus 2. Okay, and then so if I were to go into the graph section, and then yeah, so I think the most optimal solution is by graphic display calculator. Every time you do a graphic display solution, you have to draw the graph like so. Label intersections as necessary. So we have something like this. Hold on, I'm just going to reset the window. So it looks something like 0 to 10, and then great. Looks like this. So we have a function that goes like this, and then boom. Just like so. Should kind of look like the one that you have above. And then here, we're just going to say this is the particular value we're looking for. And we're going to set t equals, and then we're going to find the intersect, which is the one that we circled. In order to do so on the TI-84, you're going to second and then the trace button. So essentially, you're pressing the calc button. Just go click the intersect button. You would set the bounds, and you get the 0. T equals 1.69 seconds. So of course, include your units and write things to 3 significant digits if they're not exact. We're going to box this, and then we're going to say solved with graphic display calculator. Okay. Okay, so contrary to the Alberta curriculum, you actually don't need to show the window settings. So all I have to do is graph and say solve with GDC. Great. So to solve part B, we see that we have to find the range of values for t for the displacement of the the particle is increasing, or in other words, the velocity is going to be positive. So we see there's a second root right here. We can say the zeros of the equation by GDC are t equals 1.69 seconds, and we can repeat the process on the calculator for the other 0, and that gives us just about something close to 6, so 6.12. Okay, and how we did this, of course, we would have to draw the graph again, just like so, and then something like that, and then we get that just like so. And then of course we want to find the range of values for t for which the displacement of the particle is increasing. So we simply want t greater than 0 within the domain that we're given. This implies that we have 1.69 is less than t and is less than 6.12. Now here you want to keep your essentially your signs here non-inclusive of the equal sign, just because at the specific endpoints, if it's closed, at like for example t equals 1.69 etc., it's not truly increasing at that specific point, hence why you want to keep it open just like so. So your interval will look like this, or an alternative way to represent this is t belongs to the range of 1.69 to 6.12. So that's the same thing in interval notation, either would be accepted. Now for part C, we ran out of paper, so we're going to add some more. Okay, so for part C, what we're going to do is we are going to find the displacement of the particle relative to O when t equals 10. So O is like this arbitrary point. What we need to do is, in order to get displacement, we need to take the integral of velocity. So displacement, we're going to write that in terms of d, equals the integral of essentially v with respect to time. And we can essentially take the integral of 2 sine 0.5 t plus 0.3 t minus 2 with respect to time. And then we can solve this integral to be negative cosine of 0.5t. Oh, looks like I dropped a 4. So negative 4 cosine 0.5t, and then plus 0.6 t squared, oh no, 0.15 t squared minus 2t, and then plus c, of course. And we want to set this equal to O, and so essentially at t equals 0, cosine becomes essentially positive 1. So at t equals 0, d equals, and then negative 4, just like so, and then plus c equals O, and then theoretically c would be equal to O plus 4. And now we want the displacement of the particle relative to O when t equals 10. So now we just want to plug t into this equation that we have right here, and then we want to solve that in terms of O. So we got at t equals 10, we got t equals 10, d equals, and then we plug this onto your calculator, so negative 4 cosine 5 plus 0.15, sorry, 0.15, just like so, 100 minus 20 plus O plus 4. And then solve this in our calculator to be roughly about, give me 1 second, so 0.15 times 100 minus 20 gives us about O minus 2.13. And of course we want this relative to O. So what we need to do is we can picture this as like at t equals 10, like suppose this is O, and then this would be like O minus 2.13. And so the distance between here is going to be, the distance is O, sorry, it's going to be O minus O minus 2.13. And of course, like distance here is going, or sorry, displacement is, isn't this negative? Displacement? Exactly. So then why is it positive? It's supposed to be negative. Okay, so according to our calculations, we want to take the final position, and they want to subtract the initial position, which is O. And then so we get the final, sorry, this would actually not be distance. This would be displacement. And then this would be equal to negative 2.13 meters. So this is going to be the answer for question 5C. And this should be all you need to do for 6 points. When you do graphs, make sure to draw under the domain, and then make sure you write solved with GDC. And actually in problem number 2, you'd also write solved with GDC. Okay, and then for number C, just make sure that you recognize that distance is going to be the integral of velocity with respect to time, and you just want to solve using the constraints given. Great. So now for question number 6, we are going to see a linear regression problem. So here it asks, like, we have this table right here, which is a lot of values. And what we need to do is we need to solve for Pearson's product moment correlation coefficient. And it's actually, IB is so kind to give us that this is all equal to R. So even if you had no idea what product moment correlation coefficient is, you can think of R, you can think about the R squared value, and you can think about how when you do linear regression, you always get that R value that you can put on here. So what we need to do first, I think, is to go into your calculator's, basically your stat option, which is how you generate tables. On a TI-84, you click stat, click edit, and then you would put essentially all of the first row right here into list 1, and then all of the second row into list 2. And then in order to find the correlation coefficient, by default, it's not turned on with the TI-84, so you have to go into catalog, so second 0, and then you would scroll down to wherever you see diagnostic on. And then once you click that and you press enter, what you're going to do is you're going to go back into the stat menu, click calc, which is just the right arrow. You're going to go into lin regression, so that's option number 4. Make sure your X list is going to be list 1, Y list is list 2. You're just going to calculate, and you're going to get that the R value is 0.901. So this is going to save you a lot of hassle and a lot of the math required to solve this manually. All you have to do is just put everything into your calculator, press a few buttons, and this is the value that it gives you. So of course, when you actually represent this on the answer paper, you would write A, and then by the linreg function on GDC, we have R equals 0.901, just like so. And then for part B, we're going to see the teacher estimated his score on test B to be 27 to the nearest integer using the following calculation. So we see that essentially they use the regression equation on this person on his test A score, which is correct because we're basically converting from test A to test B. But the major problem is that you can see a lot of these values right here. They all line up somewhere between the range of 50 to 100. So if suddenly you do this regression on 10, it's like way outside the range. So if how I were to answer this, one way to do this is to just say the regressed value of 10 on test A is outside of all values used for the regression. It's outside of here the range outside used for the regression equation. So the regressed value of 10 on test A is outside the range of all values used for the regression equation. Okay, and therefore you would just say therefore it is not appropriate. Great. Now for C, we would have to give a reason why this method is not appropriate for this person. So here we see that we went from test B to test A, which is actually opposite to what we regressed initially. So this equation is essentially taking the value from test A, and we're solving a value for test B using that value on test A. But how this works is we can't actually reverse this. Like statistically, it's not valid. So one way we could just say is, yeah, so we cannot use the regression that estimates test B scores using test A scores in reverse by estimating a test A score with test B. Great. So that would be pretty much a valid reason for C. And then make sure you indicate part 1 as well. So here you would write C and then just part 1. And then part 2, hopefully there's enough room in the last 2 lines here. Use an appropriate method to show that the estimated test A score for this person is 86 to the nearest integer. So what we need to do is we already have the lists in our TI-84 calculator. And what we need to do is we need to do the same linear regression. So go into stat, calc, and then linear regression. But this time, instead of the X list and Y list, we're going to swap them around. So the X list should have list 2, Y list should have list 1. And then basically, I would personally store this into a Y variable like Y1. And then we would calculate. So now we get the equation 0.987x minus 3.22 equals like y. So here we have by lin reg, which is our linear regression, and then of like essentially we define L2 and L1 like so. Typically on the test you would probably define like what L1 and L2 are at first, so you'd probably say L1 like let L1 represent test A, let L2 represent test B, and then of course instead of doing these arrows you would represent them on the actual answer like page right here. But so far we're just gonna write it like so. So by lin reg L2 L1 we have, and then we would want to use the consistent variables. So x equals 0.987 y, and then you want to minus 3.22. Now what you want to do is you want to substitute this value as being 90. So his B score, which is going to be our y, is going to be equal to $90, right? So we're going to substitute this value equals to 90. So 0.987 times 90 minus 3.22. Hopefully this gives us a value close to 86, which we get to be 85.61, which is approximately 86, just like so. And this is our final answer. Great. Now we're going to take a quick 5-minute break, and then we're going to move on to section B, which are the harder, more application-based problems. And we're just going to give you 5 minutes to take a break.
Hi guys, I'm Maggie and I'll be coming back to you with section B of this paper 2 and starting off with question 7. So the question asks, consider the function defined by f of x is equal to 3 over 2 times e to the power of x minus 2 where the domain is 0, x is like bigger than 0 but smaller than 4, and a show that the inverse function is given by the 2 plus ln of 2x over 3. So to do this question, all you have to do is write it as, first of all, f of x is equal to 3 over 2 e to the power of x minus 2. And then by inverse, you just swap the x and the y, so x is equal to 3 over 2 times e to the power of y minus 2. By multiplying both sides by 2 over 3, we get 2 over 3x is equal to e to the power of y minus 2. And then you can just ln both sides to isolate the y in this case. So ln 2 over 3x is equal to ln e to the power of y minus 2. Using log laws, you can get it so that ln 2 over 3x is equal to y minus 2 ln e, which you know is just 1. Therefore, ln 2 over 3x is just equal to y minus 2. So therefore, y is equal to ln 2 over 3x plus 2, which is exactly what is shown over here. In fact, you can probably write it the way that they wrote it. So y is equal to 2 plus ln 2 over 3x, which would be your final answer for this question. Okay, so looking for B. The graphs of f and inverse of f intersect at 2 points P and Q as shown on the following diagram. Question B asks you to find PQ, which would be the distance between the 2 points over here that would look somewhat like this. Alright, so we know that f of x is equal to 3 over 2 e to the power of x minus 2 with x is bigger than 0 but smaller than 4. So then the inverse of x, as we shown in part A above, is equal to 2 plus ln 2 over 3x. From the distance between 2 points, x1, y1, and x2, y2 is given by the formula x1 minus x2 squared plus y1 minus y2 squared, as you should know for the distance formula. And if you just use your graphing display calculator, you can find the points P and Q. So from your GDC, P should be 0.264, 0.264, and Q should be 2.52 and 2.52. So now if you just plug this into the distance formula over there, you can get that D is equal to 2.52 minus 0.264 squared plus 2.52 minus 0.264 squared. And it doesn't really matter in this case whether you minus the 0.264 or minus the 2.52 first, because it gets squared after, so the polarity here doesn't really matter that much. And you can just use this to get 3.190465, which will give you roughly 3.19, which will be your final answer for this question. Okay, so looking into part C of this question, the graph f is reflected in the x-axis and then translated to the parallel of y-axis by 5 units in the positive direction to give the graph of a function g. So simply put, f is reflected in the x-axis and translated 5 units up. So the first part of C asks for an expression for g of x. So we know that based on the fact that it's just reflected in the x-axis and translated 5 up, g of x is just equal to negative f of x plus 5. And then looking at the second part of C, we're looking for the domain of g. However, we know from the original question that the domain of f of x is 0. X is bigger than 0 but smaller than 4. But because none of these transformations actually affected the domain, because the reflected in the x-axis only affects the y-coordinate and translated 5 up only affects the y-coordinate, the domain of G will actually still be 0 is less than x, which is, 0 is less than x, which is less than 4. Okay, so moving on to part D. Solve the equation that f of x is equal to g of x and give your answer in the form of x is equal to a plus 1b, where a, b is real. Okay, so f of x is equal to g of x. So from our questions above, this is that 3 over 2 e to the x minus 2 is equal to negative 3 over 2 ex minus 2 plus 5 from your questions above. So from this, what we know is that 3 ex minus 2 is equal to 5, because you'll just these will just add and then cancel the 2 from the bottom. So then e to the x minus 2 is equal to 5 over 3. To isolate the x minus 2 here, we can do 1 ex minus 2 is equal to 1 5 over 3, so that by log laws, we know that x minus 2 1 e is equal to 1 5 over 3. So we know that this is just 1, so x minus 2 equals to 1 5 over 3. So therefore x is just equal to 1 5 over 3 plus 2. However, it asks you to put it in the form of x equal to a plus ln b, so you can just write it as x is equal to 2 plus ln 5 over 3. So that will be your answers for section B. Okay, so now we can move on to to 8. So Sault Ste. and Rockall are small islands in the Atlantic Ocean in the same time zone. On a given day, the height of the water in meters at Sault Ste. is modeled by the function h of t is equal to 1.63 sine 0.513 t minus 8.20 plus 2.13, where t is the number of hours after midnight. The following graph here shows the height of the water for 15 hours starting at midnight. At low tide, the height of the water is 0.50 meters, and at high tide, the height of the water is 3.76 meters, and all heights are given correct to 2 decimal places. Looking at A, the length of time between the first low tide and the first high tide is 6 hours and m minutes. Find the value of m to the nearest integer. Okay, so what do we know? First, writing down the information that we do know, h of t is equal to 1.63 sine 0.513 t minus 8.20 plus 2.13, where t is the number of hours after midnight. We know that low tide is at 0.50 meters, and high tide is at 3.76 meters. Looking at this as on a graph, we know that h of t is here, t is here, and then the graph will look roughly something like this with 15 at the very end. And we know that this right here between the high and low tide will be 6 hours and m minutes. So what do we know is that for a sine graph, from the min to the max is equal to half of a period. So, and to find a period is just equal to 2 pi over b. And because we know the b from this over here is just equal to 2 pi over 0.513, which is equal to roughly 12.2479. And because we want to give this correctly, we'll write this as roughly 12.2, which should be the answer to A. Okay, looking at question B. Question B asks, between 2 consecutive high tides, determine the length of time in hours for which the height of the water is less than 1 meter. So we can look at this as on a graph again, because to solve this, we can pretty much just use our graphing display calculator. So drawing the graph right over here, we know that h of t is on the y-axis and t is on the x-axis. And then the graph will look somewhat like this. Well, actually, this is a bit high. We can put it like this, with 6 is up here. And we're looking for this here. We're looking for 1 meter. So the 2 points here is what we're looking for, and we want the distance between these. Okay. So by your graphing display calculator, the 2 points will be 3.5692 something 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 and 1, because we're looking for the intersection between that and the 1 meter, and also 6.70684.1. So because we're just looking for the length of time in hours, all we actually need to do for this question is 6.70684 minus 3.5692. We should actually put dots here because that's not the full number, which will equal to roughly 3.13764. The length of time in hours is therefore roughly 3.14 hours. Okay, so given our current limitations on time, we'll be finishing up with the rest of the questions, including 8C, D, and E, and also all of question 9 for this paper 2 tomorrow in tomorrow's stream. Okay, well, so thank you all so much for coming, and we hope to see you all tomorrow. Thank you.
Sorry if any parts of the stuff we did today is a little confusing. Nana's brought our brains to heavy, so it's a little sad. We will re-record some of the sections and post the full video on YouTube later. Thank you so much for coming.
Thank you.